Hey there, I'm Carter C., the Science Geek. Absolutely no relation to Bill Nye the Science Guy. Today, I want to talk to you about magnetism. I've always been attracted to magnets. Get it? A magnet is a metal or other material that attracts easily magnetized substances like iron. In fact, the Earth is one big magnet. I have the Earth here. Not really, but, if I squish it, it might hurt somebody. And I got magnets. So, the Earth is one big magnet, right? And magnets have poles, like north and south. We know this, right? And the Earth is going to be represented by this almost spherical magnet. And the magnetism on the pole is stronger on Earth. So it would basically look like this. So the magnetism on Earth, or the magnetic field, kind of looks like this, because the magnets are stronger here and here. And to demonstrate this, all you have to do is put two magnets on the Earth and a metal rod, such as this. It's on a magnet. This metal rod will be attracted to it because it's the North Pole, I think. But we'll talk more about that later, how the Earth is a magnet. The first thing I'm going to tell you about magnets is magnetic poles. Every magnet has two poles, north and south, as I talked about earlier. This is where the magnetism is the strongest, like me. What? You don't think I'm strong? I'm appalled. We can actually test how strong the poles are on a magnet with this magnet machine of science. Unlike poles of magnets attract each other, and like poles of magnets repel. So, if I take these two magnets, see how that attracts? Well, if I do this, it repels, and it's repelling in a ball, almost, around the magnet. And if I do this, on the other side, it's the same story. Now, to represent magnets on the poles, I have these two very strong magnets, the tiny cubes. And we put them on the poles of... And again, a metal rod would go towards the most attracted point. We can actually increase the amount of magnetism just by switching up the magnet a little bit. And now the metal rod is attached from all angles. Okay, guess we have to put this away now. It's broken. Ooh. It's gone. Next, I want to talk about law of attraction. Law of attraction means anything with parallel electrons, and I mean the way they spin is all the same, will be attracted to magnets. Anything with electrons spinning the opposite direction, so like this, will not be attracted. Let's talk about magnets in more detail. A magnetic domain is a region within a magnetic material in which the magnetization is in a uniform direction. This means that the individual magnetic moments of the atoms are aligned with one another, and they point to the same direction. When cooled below a temperature called the Curie temperature, the magnetization of a piece of ferromagnetic material spontaneously divides into many small regions called magnetic domains. I have a domain. It's called YouTube. Magnetic fields are an area around a magnet in which certain materials can be attracted. A magnetic field is strongest at the poles. The Earth also has magnetic fields. With its core of nickel and iron, the magnetic field is like a bar magnet. Yeah, whenever I'm around one, I feel barred in. Examples of magnetic material found on Earth are a natural mineral called magnetite, iron, cobalt, and nickel. There's actually one more. It's called neodymium. It's the strongest magnet you've ever seen. Trust me. Ferromagnetic materials have large positive susceptibility to an external magnetic field. When a magnetizing force is applied, the domains become aligned to produce a strong magnetic field within the part. Iron, nickel, and cobalt are examples of ferromagnetic materials. Permanent magnets and temporary magnets differ in that permanent magnets are not influenced by external magnetic fields. They remain magnetized. Permanent magnets are made from hard materials that stay magnetized. Temporary magnets cannot stay magnetized. On their own, temporary magnets cannot stay magnetized on their own. They are made of soft materials like iron and nickel and will not attract after a strong external magnetic field has been removed. Magnetic induction is the process by which an object or material is magnetized by an external magnetic field. Induction, more like reduction, because, it reduces the distance by inducting the two things together. You probably know. An electromagnet is a soft metal core made into a magnet by the passage of electric current through a coil called a solenoid. A solenoid is a coil of wire used as an electromagnet and converts electrical energy to mechanical energy. Magnets can lose their strength if heated above a certain point called the Curie temperature, but also can lose strength naturally over time. To increase a magnet's strength, you can use magnetic induction using the solenoid coil mentioned earlier. Increasing the turns of the coil can add strength, along with increasing the current flowing through the coil. You can also place a weaker magnet next to a strong magnet. And the sources are Wikipedia, Mr. Brock's Nearpod, National Geographic, Friday's Law, and Google. And I have two pictures, an example of a magnet and an example of a magnetic field. The first picture is from cbanggood.com, and pic 2 is from nationalmaglab.org. And that is the end of Carter C., the Science Geek.